All right.
2, 3.
Hello, Seattle. Hey. So I am Arvind Nilakantan. I am here to talk about Unreal for mobile. I see a lot of enthusiastic hellos, which is great. So there's a lot of folks working on mobile-based Unreal Engine project or interested in Unreal Engine for mobile, which is excellent. Good times. A quick run through of the agenda today. I will be doing what is Unreal for mobile introduction. I'll also talk about Android-specific workflows, and I'm talking about Android-specific because there is a lot to cover. A lot of this will also, of course, translate to iOS, but I'm sticking to Android for now, which will include like editor setup. How do you use the old and the new mobile preview? How do you do chunking? The new Android game development extension. And then how do you also increase your C++ iteration times? I'll also talk about mobile optimization, or rather mobile-specific optimization, which will run through how do you optimize your meshes, textures, talk about PSO caching, gathering, pre-caching, console variables. And when you're working in a very large team, especially when you're working on open worlds, streamlining your development plays a big part. So I'll be talking about Horde, where I'll walk you through how to set up the CI/CD pipeline. How do you do device management, especially when you're doing testing, both automated and manual testing? And then, of course, the future of mobile. Everyone has the same question, which is Nanite and Lumen on mobile. When is that coming out? Well, I'll talk about that too. So that's pretty much what today's talk is all about. There might be a lot of things that you folks know. I think there's a lot of experts in here who are working on mobile. So if you might know a lot of these things, and I hope by the end of this talk you learn something new that you didn't previously know. And if you're completely new to mobile, I think you'll pick up some nice tips from this talk. So introduction, I'm Arvind Nilakantan. I am a solutions architect. I've been making games for the last 15 years. I typically run around in India, in the Middle East, and Africa, providing technical direction to mobile developers. I am from India. And I also lead instructor-led initiatives where anything that requires infrastructure for training, I also lead that initiative within Epic. Now, mobile is very important for Unreal Engine. I think it was also in the keynote, so it's clearly very, very important. And you're not alone when you're making AAA games using Unreal Engine on mobile. There's a lot of folks doing it. We have Tower of Fantasy, we have the Oregon Trail, we have Ni no Kuni, and of course Fortnite itself. And from my neck of the woods, I'm from India and from Asia, we have Raji and Final Fantasy VII, Blue Protocol, all using Unreal Engine for mobile development. Now, a couple of months ago, I was in Unreal Engine or UE Fest Prague, where I gave a talk on AAA gaming on mobile. And this really is kind of like a sequel to the talk. There is a little bit of overlap between that talk and this talk a bit. But if you're interested to know about how to do build size optimize or reduction and talk about like a little more performance optimization and debugging, going deeper into debugging Android projects, that would be a good talk to look at on YouTube. And this is like a part 2 of that talk. So let's look at Android-specific workflows, including editor setup, mobile preview, chunking, and ADGE, or AGDE. So if you are working on Android, there is a really helpful doc on the Epic developer community where you can go scan that or go to that link, and that's where you can set up your Android editor or Unreal editor for Android deployment. You usually get it in a few tries. And then you could scroll down, make sure that you have your Google Play services if you're using that, and then make sure that your SDK, NDKs are all set up correctly, and you're good to go. For this talk, I am using a variation of Cropout on mobile. For folks who are unfamiliar with it, Cropout on mobile is a cross-platform game available in the Epic Game Store, or Epic Marketplace rather, and it works on PC, and it also works on mobile. And what you're seeing on the right-hand side is me running it on mobile. Now, what I did, because this is an open world topic, I took this project and put it in a massive open world. Just dropped all the assets in there and made it work in a 2 kilometer by 2 kilometer world. And you know what? I just tested it out after making sure the UI, all of it works, and it just works. on Android. I didn't have to do anything massively different. In fact, I was just like, if you look at the FPS, it runs at a good 60 frames per second, no problem, just like that. I didn't have to do any massive changes. And this is all thanks to a lot of improvements that's been done behind the scenes in the engine, which helps with this kind of massive world development in mobile. So one of the first things that happens behind the scenes when you're working on a massive world is the landscape GPU culling. Now, all the landscape tiles that you're seeing are just very compact instances, and they can very easily be culled on the GPU. And we do culling only for lot 0, because that's the closest to the camera, and it's very fast and very efficient. There's no support for shadow views yet, and the cool thing is it's enabled on all platforms beginning with UE 5.4. It is deactivated if you're using Landscape Nanite or Lumen, which anyway, most of the phones don't support Nanite and Lumen, so for mobile, we are actually pretty good. And if you're looking at the cryptic foot or the picture on the side, like what exactly does that mean? On the top side is my phone. I was running this screenshot is from GPU culling turned off in the first screenshot, and you can see that rectangle is my phone. And you can see a lot of the landscape were rendered. But if I turn on GPU culling, the landscape GPU culling, you'll notice that like a bunch of landscape tiles just disappeared in the view where I'm not looking at it. And this just works. With landscape GPU culling, massive open worlds on mobile works. Now, if you're curious how I went about setting up this world, it's quite easy. Just went up, created a new open world system, open world level rather. It's by default a 2 kilometer by 2 kilometer world, and I just populated the world with a bunch of assets. Now you could do this with PCG, the procedural content generation tool, or you could use like editor utility widgets. I'm a programmer, so I just went in and wrote like a quick Python script, and it just goes about just dropping a whole bunch of static meshes. And I just ran that Python script, and it just places all the buildings from a particular folder and just drops them all in the world. I repeated the same thing for props and also for some animations. Created a landscape mesh added a landscape material to the landscape mesh, which is the default material provided by the Cropout project itself, and that's it. And then a few tweaks here and there to add the UI to make sure that it works on the same game works on mobile as it does for the non-open world project. All of that was done, and this is pretty much all I did. Now, the first thing that you would want to do when you create an Android or iOS project is to preview that game on Android. Now, you'll notice that there is a little button on the top which has the Android icon on it. And that is the one that will then recompile the shaders to show that on Android, to preview it on what that will look on Android. Now, if you don't see that button, because you need to then enable Android preview, you enable Android preview by going under settings, and under preview platform, you have like Android OpenGL Mobile or Android Vulkan. By the way, on 5.5, this UI has very slightly changed, but it's in the same place. Once you do that, you'll notice that that icon shows up. Once you have this mobile preview or Android preview on your editor, the next thing you'd probably want to do is run it on your emulator. There is a mobile preview which is old, which has been around for a while, and you'll notice that a lot of shaders don't really show up in those in that emulators, and that's because it's an experimental and it's an old way of working with it. You don't want to use this anymore. But I'll just show you how to use this anyway. So if you want to enable the old way of mobile previewing, you go under Editor Preferences, go under Experimental, and there is you have the Allow Vulkan Mobile Preview and Mobile PI with Preview Device Launch options. Once you have that turned on in your editor settings or editor preferences, you'll notice that there is a whole host of very, very, very old devices that will just show up. Like S9, S8, S7, Pixel 2, which no one uses, but that exists. It still exists. And you don't want to use this anymore. So now we have a new and experimental currently mobile preview, which works in tandem with the with the Android provided emulator. So that can be turned on. You can see that there's crop out already installed on that, and you can see if I go under platforms, the emulator now shows up, and you can deploy it directly to the Android emulator, which is the preferred way of working. So how would you turn that on? It's quite easy. If you have the latest version of the Android Studio, you don't have to do anything, but if you have an older version, just go to the Android emulator archives, download any Android emulator that's greater than 35.2.7, install that into your Android Studio. Make sure that you go to under your users and Android folder, create a new INI file called advanced features.ini. You go about doing that. Fairly slow in typing, so I'm INI. Yes, I do want to change the extension. Yep, and then I will open that up in Visual Studio Code, and I need to add 2 lines to it. One is Vulkan turned on, and GL Direct Mem is on both those things. GL Direct Mem will enable hardware acceleration. Once you have those 2 in there, save your file, go back to your Unreal editor. And I want to have a caveat. This preview only works if you are running Vulkan builds. So if you have ARM64 or x86-64 builds, and with Vulkan, you're good to go and run the game on your emulator, Android emulator. You have that turned on. In your Android Studio, make sure that if you have an older version, just make sure that you have the right version of the emulator turned on by going to the SDK manager, going under SDK tools. And you can see that the emulator is running 35.2.7, which is the right version, and anything above that works too. Then just go create an emulator by going under Virtual Device Manager. Just create a device. Make sure that you have, and here all the latest and greatest versions of Android is available for you as OS. So I'm just creating like a Pixel 6 Pro, and Vanilla Ice Cream is the version that is the beginning version before the emulator is supported. So I'm setting Vanilla Ice Cream as the OS. Give it some name, and what's the default orientation. Finish it up, and that's it. Once you have that set up, just click on play, and now the emulator is turned on or will start. It'll just take a little bit of time, and once the emulator is on, it works exactly like your typical Android device, and this will be available as a device in which you could launch your Unreal Android game into. So once that's turned on, once it's turned on, just go into like platforms, as you would typically do if you have a device connected to your PC or Mac, right? Just go there and you'll see the emulator is there. Now you'll notice that there is a little warning triangle. That's a bug. That'll be fixed when we come out with 5.5 release version. But you just turn it on and have the emulator connect to your Unreal editor, and you just build the executable on that device. That's it. As simple as that. And this is a new version, and we'll keep chipping away on it. I'll talk more about it in a little bit of time. The next thing I want to talk about is when you're creating these large worlds, you need to have your asset or your game isn't going to be less than 2 gigabytes. It's probably going to be a lot bigger. If you go under Android, even if you have the large OBB files turned on, and even though there's like a 4 GB limit, and in fact 2 GB is what Google Play allows, but a 4 GB limit in general in the OBB file, your world might probably be bigger. Like Fortnite is much bigger than 4 GB, which is why you need chunking. For folks who are unfamiliar with chunking is kind of like your DLCs. You're able to download additional files after your initial install of the game itself. To enable chunking, just go under your project settings, go to your packaging, make sure that you use your pack file, that you have use pack file, and you are generating chunks. Chunks is where you're removing certain files or certain assets from being included in your build. Now you can check to see if the chunks exist or not by just going under the asset audit part of your editor, and you'll see that right now there are no chunks. And we'll come back to this asset audit in a little bit of time. Now, in order to create chunks, there are a couple of ways you can do it, but the way that kind of works all the time is going and creating a data asset, a primary asset label, And in the data asset, I'm just going to create that asset inside the directory where all of my static meshes or meshes that I want to include as part of my chunk is going to be. I'm going to create a chunk ID, which is greater than 0, and add cook rules about saying that it should always be cooked, include references, save that file. And now I did the same thing. This was under buildings. I did the same thing for all the meshes under the crops folder also. And now all I have to do is package the build. So I'm just going under Android. I'll package the build. And what will happen here is the buildings, all the assets under the buildings folder and all the assets under the crops folder will be separated out from the build. And now if I go back to the asset audit, and if I click refresh, add chunks, you'll notice that now there's 3 chunks there. There's chunk 0, which is the base game itself. And then there's chunk 101 and chunk 102, which is the name I had given. And you could go to the references and figure out, are they referencing the right assets? And they are. So you can see the chunk 101 is referencing all my static meshes in the building portion. And the chunk 102 will be referencing to all the crops. Now here is something that will be quite strange if you are developing for Android the first time, which is I created these chunks. I have the OBB file. Now OBB file is just an archive file, right? I can just open up the archive file. And in theory, I would have thought hey, if I open up the OBB file, the chunks should be left out from the OBB file, because that was the entire point of this exercise. I want to not add to the size of the OBB. But now if I go inside the OBB file, you'll notice that all the chunks exist there, like this pack chunk 101, pack chunk 102, all sitting nicely and cozy in there. But we want to exclude it. So in order to exclude those chunk files, you have to do one more step. In your default engine.ini file, you got to add a OBB filter which says exclude these chunks when you're making the build. So I'm going to add a line which is called plus OBB filters, and I'm adding a wildcard which says anything that has the name star pack chunk 1 star, because my chunks are 101, 102. I'm going to add that, and then I got to make a build again. After I make a build again, if I go to my OBB file, open up the archive file, you'll notice that this now does not have the chunks. Like 101, 102 is all excluded from my OBB file. And now my OBB is significantly smaller. But it's not like these chunks got deleted. They do exist. So if you go under saved, staged builds folder, under where your Android file is, under crop out content packs, you'll notice that that's where all my chunks exist. And now the OBB file contains just chunk 0, which is the base chunk, which is required for your users or players to install the game. And any other things that's part of the initial build that's not excluded. And the rest of it you can download from, let's say, a CDN server, which you can learn how to do that by scanning that QR code. That talks about how to host the chunks on a server, and you can download them after the initial build is done. So there's also a QR code, and there's also the URL for folks who are watching it in live stream and don't have a phone handy with you. So that's how you have chunks done. All right, let's go to the next part, which is all about debugging your Android projects. How many of you have seen this happen, where you open up the game and it just crashes? So to debug PowerPoint, just restart it. But to debug Android projects, you can extend the Android game development extension for Visual Studio. Install that, and then go and then generate the Visual Studio projects for your project. So right-click, generate Visual Studio project files, and you're good to go. Now, once you generate the files, go to your Android and package the project, because Visual Studio cannot package the APK file for you. It's only Unreal Engine which can do it for you. Once you do that, in Visual Studio, make sure you have either debug game or development game set up for Android, and set the target to be the target game that you're debugging. And you'll notice that I have my phone connected, like that's the SM-S911 is my Samsung phone. I have it connected to my device. I click on play, and this will then automatically launch the game on my device, and I'll know why it's crashing. Let's see that in action. Now, sometimes you might face this problem. If you're running Android 14, especially the older version of Android 14, it's fixed on the later versions of Android 14, you might get this SIGBUS error, which can be fixed by going to your debug properties. Under debugging, there is a LLDB post-attach commands. Again, this is fixed, and then add this thing there. If you're looking at like what that thing is, that's the thing. You add that thing there and that line there, and you should be good. You won't get that error, and that only happens on Android 14 for older versions. If you update to the later version of Android 14, you're all right. But this is what the experience will look like. You have I clicked on play, and on the left-hand side you can see that's my game. It's connecting to my debugger. It's attaching to the process. It'll take a little bit of time. And if there is a crash, it should just find that crash. Let's hope that crashes this time. Let's see, crash. That crashed then. And now you'll notice that the crash suspiciously is in a class called crash actor, but it crashed and it was able to find the line in which it was crashing, which is super helpful. And using the Android game development extension, you can also add breakpoints if you're running a C++ project, and so it's super helpful. I'm a programmer, as you saw. I like using Python scripts, but this is super helpful. Like I can just go in there. I don't know who wrote abort there, crazy fellow, but that's what happens, and that's super helpful. And talking about C++ projects, you don't want to keep packaging the project over and over again if you're just making changes to the code. Now there's a useful little utility in the editor. If you go under your project settings, under Android settings, there is a useful checkbox there called don't bundle libraries into APK for quicker iteration, experimental. So if you, and you can also, if you're like cool and you're like, I want to go to default engine.ini and write it myself, you could do that too, which is what is the don't bundle libraries in APK. So if you set that as true, next time you're going to be packaging the build, it's going to exclude all the assets. It's only going to include your C++ classes, which believe me, it greatly improves your C++ iteration times. All right, let's look at optimizations, which talks about meshes, textures, CVARs, PSO caching, which everyone is talking about. So on mobile, Nanite isn't supported. So that's one thing off our head. But if you have a mesh that's Nanite supported, it automatically goes back to the fallback mesh. And sometimes the fallback mesh might be quite heavy, and you don't want to use it in your mobile game. But it's a cross-platform game. You don't want to just reduce the static mesh complexity. So instead, what you can do is if you go to the mesh, and if you scroll under, and make sure that you have LODs turned on and have LODs generated. And under LOD settings, I have 3 LODs in this particular mesh. And under minimum LOD, there is a plus button. If I click on the plus button, I can now set specific overrides for mobile. And I can say like, for mobile alone, when I'm packaging this game, only use LOD2. But for the other platforms, other platforms just use LOD 0 or Nanite, whatever works. But for mobile, use 2. And this means that first your game will be a lot more performant on mobile, and also there will be a significant reduction in your game size. And if you do it for one mesh, and I'm sure you have a lot of meshes in your game, you can copy that setting from that one mesh where you changed it, and select all other meshes. And you can paste the same LOD detail so that you don't have to do it for like thousands of meshes again and again. Just doing it once on one mesh will help you out. After you do mesh optimization, the next logical step is texture optimization. Now, texture optimization is also quite important because you don't want to have like 4K textures in your game. So this texture is a 2K texture, but I don't want this 2K texture in my game. I probably want to have it as a 1K texture. So if you have the texture open, it's important to set texture groups to all of your textures. And the reason why you have to set texture groups is once you have all of your texture with texture groups selected, you can go under platforms and device profiles. And the device profile is a super useful tool where it lists pretty much all the devices supported by Unreal Engine. And you can set overrides for each platform when you're packaging it for that particular platform. So you can notice that Android is over there. And you can also notice that there's a bunch of other Android platforms under it, right? But any changes I make on the parent Android profile will automatically propagate down to other Android devices also. So I go under the parent Android, I open that up, and I can now go under the texture LOD settings. And remember the texture groups, I can go under each texture group and say, when I'm packaging it for Android, reduce the 2K texture and clamp it to be a 1K texture. And you can do it for all other texture groups. Maybe for the hero character, you want it to be a 1K texture or a 2K texture, but maybe a boulder that's very far away, you can just kind of set it to a 512 size. And while we are on the device profiles, the other thing that you could also do is add overrides using CVARs or console variables. In here, while again developing for Android devices, you can say I don't want to have grass turned on or wind turned on, or maybe you don't want to have physics in crop out. There's the little guys who are walking around have a hat that kind of bobs up and down that uses physics, but that's I don't care about it on mobile, but maybe it looks nice on PC. So I can turn that off just for Android using CVARs in the device profiles. Next up is shaders. When you're optimizing shaders, the first things I typically like to do is go to the platform stats button on the top and look at the performance, the instruction count on each of this shader. And if it's quite high, then you know it's quite high on mobile. But you'll notice that when you turn Android on in the settings, there is a warning that shows up which says it is in fact unable to extract the instruction count for that particular shader. And that's because Unreal Engine needs a Mali offline compiler in order to calculate the instruction count. So if you go under the editor settings and material editor, you'll notice that it's empty. So you need to go to the developer website, download the Mali offline compiler, and then point that Mali offline compiler exe file in the editor, and now if you go back, you'll notice that, hey, the warning is gone, and I can see the instruction count. That's pretty helpful. And finally, you don't want to keep writing new shaders for every platform that you're going to be targeting. And that's why we use feature level switch, and this has been around since Unreal 4.26 and above, and it's something that we use quite often in Fortnite, where you can just say, if I'm going to be having a shader that's only going to be, say, working on ES3 devices, and I can pass in a node which will only get compiled when I'm compiling for a ES3 device. But if I'm writing the same shader for SM6, you can have it rerouted to a different set of shader nodes, which is quite useful. Now, I wanted to get a screenshot of me doing this in crop out, but crop out was very efficient. So I kind of stole this from my colleague. And this is where on the left-hand side, you have a performance graph that shows basic performance, like frame time, game, and render thread time. And once you move your camera and new objects get into your screen, you can experience a very bad frame drop and hitches. And I think most developers who have worked on AAA games must have faced this problem. And it has many names, but because we ran insights, we know that this was caused due to a shader compilation hitch. The modern name for this is PSO, or pipeline state object, and this is a PSO hitch that's happening because it's a bunch of shaders that was getting compiled while my game was running. Now this is kind of fixed. It's hey, it's fixed. We don't need to do anything because with 5.4 and above, we already have PSO Precaching turned on. Now this is available with 5.4, but in 5.4 it only works on Android OpenGL. But if you have an Android Vulkan project on 5.4, you can just go to Android engine.ini file and just turn that on manually by putting in that console variable, which is r.pso precaching, and set that to 1. On iOS with 5.5, it's automatically enabled. And in 5.4, it did not work if you were working on a pre-computed lighting, but with 5.5, that's also fixed. And with 5.5, it's just enabled by default on all 5.5, or with 5.5, it's enabled on all mobile platforms rather. But a little bit of history, right? Because this was just so easy, and I don't know how many of you have done PSO gathering before, but this is the current system that exists before we enable pre-caching, and that's if you had that problem where shaders did not compile inside your game. What you had to do earlier was you had a developer or a tester run through the game through all possible levels and gather the PSO logs. And once you have the PSO logs captured, when you are running the game or when you're loading the game for your players, the PSO logs will be loaded and the shaders will be compiled when you're seeing that loading bar, and you'll note, and in Fortnite it will be called like optimizing game. I don't know how many of you have seen that. That's essentially just doing caching or running the PSO caches. It's just like generating those shaders for you. And this is not ideal because it obviously has very long load times, and it's also not efficient for your developers or testers to run through every part of the game. And especially if you have an open world, that's a fairly big task. Which is why PSO caching is awesome, because it just works automatically. There's no manual steps. So when a game loads, it just looks at every static, every skeletal mesh, all the materials. It looks at the landscapes and other components and starts queuing them and figures out like what are all the shaders that the user will potentially be seeing inside the game. And about a few frames before the player sees that particular object or particular mesh, the cache for that particular mesh gets compiled. And again, in crop out, it works really well. So I had to like take a screenshot of this working on that sample project I was showing. And the PSO gets compiled on task threads. And there are some fallback strategies that you can enable in case the shaders aren't compiled. The first strategy is you can just tell the mesh itself not to get rendered. So the mesh itself will be hidden. Or you can have a default material, which is like a fairly simple material that will first show up on that mesh before the original shader is slapped on top of it. Now both these default the fallback strategies are turned off, so you got to turn it on, and if you don't have it turn it on and for some reason the shader doesn't compile, you will still see that hitch happening. Before I head back to Horde, I do want to say like you could use a balance of both PSO gathering and PSO pre-caching in your game. So if you know that they're like at the beginning of the level, you know the players are going to be there and you don't mind that initial loading time, you could still continue using PSO gathering and PSO caching, but PSO pre-caching is turned on by default anyway. You don't need to do anything, but that'll take care of other places where your developers, testers haven't been to. All right, Horde. When you're working on open worlds, you're working with a very large team, and in order to work with very large teams, you don't have to have. I used to be that one guy who was making builds all day on my PC and not developing anything, and just sitting through the night, actually writing code. And to avoid that, we have Horde. Now, Horde is a CI/CD pipeline or a CI/CD engine, which is one of the things that it does. It also has mobile device management, which allows for automated testing and manual testing. Now, I don't want to go too deep into how to set up Horde because you could go to that QR code or to that link, and there is a lot of documentation on how to set up Horde. But there are three things which really caught my eye, which is remote execution, where you have the ability to compute work on other machines if you have like a PC just lying around. So if you have like a C++ compilation, using the Unreal Build Accelerator tool, you're able to just offload that work to that machine. You also have a build automation, which is CI/CD. And finally, you also have the mobile device management on Horde, which is what is very interesting for me. Now, once you have this all set up, the way the mobile device management works is like you can have a pool of devices that you can use for testing, which is connected to your team. And you can check out these devices because they will have the APK files or the IPA files ready for you when the build is done. I do want to note one thing, which is Unreal Engine, the Horde only works if you're compiling from Unreal Engine source code. It doesn't work if you're using the launcher build of Unreal Engine. So if you're using the source code, Unreal Horde really works well. So you have the APK file, but how does it even work? So if you go under server, if you go under devices, you can see all of those devices, and the pool over there is the remote UE5. So you might have testers in another part of the world, and you can add new devices in there. I'm just adding a dummy device, adding where the device is going to live. It's going to be in remote UE5. I add the IP address of that particular device. I click on save, and now that device is available for testers. And the way that will be available is if I package a new build. I go under packages, I set it up as an Android build, and I have the device manager URL, which is the IP of where my devices are going to exist. And what is the device pool, which if you remember, it's under remote UE5. I just start the job, and once the job starts, it will compile the editor, it'll compile the game, it'll automatically deploy all the APKs to all the devices that you have set up, which is fantastic. And you could then do testing. You could let your testers do the testing, and if you have automated testing, it'll also run the automated tests, all those pool of devices that you have. Now, this is not magic. This is just using build graph behind the scenes. So if you want to, and this is fairly well documented. So if you go to that link, you can use build graphs to create your own kind of jobs in Horde. Now, one of the jobs that I set up is creating HLODs. Now, when you're creating large worlds, HLODs is quite important. And notice that there is a tab called HLOD builds. That doesn't exist by default. I added it. Now, how do I add it? In order to create these HLODs manually, by the way, how many of you have created HLODs? It's a fun process, right? But I don't want to do it on my machine. So if I go under the documentation of HLODs, you'll notice there's a commandlet, and you just have to run that command in order to generate HLODs on your machine. And it's a fairly long process depending on how big your world is. So I'd like to just run that HLOD building on Horde. So in order to do that, there is automatically a JSON file. Like in this case, it's a stream.json file that gets created if you have installed Horde. And in there, in the JSON file, I can add a tab. So I just scroll down, there's a tabs over there, and I added a title, just HLOD builds, which is what you saw as a tab. And there's a template that I added called HLOD-build. And in the template, which is again, if I scroll all the way down, I can define what this template needs to do. And that is defined using build graphs. So in here, keep scrolling down, you'll notice that that's the template, that's the HLOD build. And I have arguments in there where it's referencing a XML file, appropriately named Seattle build.xml file. And this XML file is a build graph, and I can also pass in parameters in there. So whether after the HLOD is built, do I need to commit that HLOD build into Perforce, and I can do all sort of stuff. So that's the XML file. So I can open up that XML file. I don't know how many of you can see that, but that's like a build graph right there on the top. A closer look, that's the build graph. And if you want to take a picture of it, you can. But that's the build graph, and it just says like run the same commandlet I showed you in the documentation page. It just runs the exact same command on this XML file, and I can pass in parameters and whatnot. And this is, by the way, the JSON file. If you want to take a picture or want to take a screenshot, you can do that. But now, if I go back to HLOD builds, that's a new tab I added. I can create a new job. I can then say like commit the HLODs to Perforce after it's done building. I can click on start, and you can also set the build graph to say like build the HLODs nightly or periodically or after every commit. You can do all sorts of stuff, and if you click on start job, it'll just automatically create the HLODs. And this is a neat way for you to use Horde, because you can do a number of things. You can also have it run tests automatically. You could also have it generate chunks automatically whenever you're making a build, and everyone is happy, and you don't have to be the build master. So let's look into the future. Okay, I have 10 more minutes. Okay, it's the future, which is everyone's talking about Nanite and Lumen. So let's talk about that in a bit. So on mobile rendering front, like I said, we have PSO Precaching will be enabled with 5.5 automatically. There's improvements with screen space reflection. Mobile forward support for all lit decals, rectangular lights, capsule and point light with shadows will be enabled with 5.5. There is an experimental desktop deferred renderer with Lumen, which will be available only on high-end devices. There's again more improvements for decal improvements on for Switch. There's also performance optimizations, and there's also the light HDR, which will then replace the existing LDR for mobile VR platforms. So if you're working on an Android like Quest-based VR device, I would wait for 5.5 before you begin development. And future nanite on mobile GPUs will be there. It's currently being supported on very high-end devices that we are testing internally, but we are working on it. And there's also improvements on the mobile forward renderer again for VR. At 5.5, and this is most probably my next talk in another event, which is all about memory insight support on iOS and Android, which will help diagnose specific platform issues or platform-specific issues which might occur. And this is going to be pretty awesome. Which will also, and there's also a lot of behind-the-scenes work that's being done in the editor, which will enable a lot of memory savings when you're deploying to iOS and Android. And you notice that I clicked a lot of buttons and added a lot of things on my INI files, and chunking had to be excluded in my OBB filters, and it's not ideal. So we are very aware of that. So in the next versions in the future, we are working on better discoverability of properties which are relevant to mobile platforms specifically. So you don't have to do a lot of these things, but that'll, and we're also working on better tools to analyze asset cost per platform. Mobile preview, I already gave you a preview of the preview, which is how we have, but with 5.5, the mobile preview will be production ready. And there will also be on-device profile captures, which will just improve your on-device iterations for especially large games, like the ones I just showed you, like C++ iteration is a lot faster, but even things like an easier deployment to mobile, where you can even bypass the pack file creation and the slow copying that happens. All of that will be improved with 5.5 if you're developing on mobile. For the future of mobile preview, right now you saw the mobile emulator or the preview happening on one device. You can also now in the future have multiple simultaneous preview platforms running Unreal Engine, so you can Unreal Engine builds, so that you can compare, you can run tests, you can run builds, and that's also being worked on. And there's also continued on-device iteration paths, and we also have an Unreal Remote, the Unreal Remote app, which is also being revamped on the future builds of Unreal Engine. And with that, that's it. Thank you so much. That's my talk. Thank you.